Number 7, determine whether each function below is even, odd, or neither even nor odd. Alright, in looking at the 4 problems in problem 7, I notice that what I see are the trig functions sine and cosine. And I would like to take you back to the graphical representation of an even-odd function and then an algebraic approach to verifying it. First of all, when you look at your sine function, you remember, generally speaking, the graph looks like this, and going in a negative direction. Whereas the cosine function starts at the max, min, back up to the max, in a positive direction and in a negative direction. Alright, both of these are from negative 2 pi to 2 pi. Now, the definition of an even function is if you were to reflect the right side of your graph over the left or over the y-axis, all points would match up. That makes this an even function, graphically speaking. And if you were to reflect the right side over the y-axis and they don't match up, but you reflect over the x-axis and everything matches up, well then you have an odd function. That's one way to look at it. And the other is that an even function is symmetric, it is even because when you take any value on the right side, you can find a corresponding point on the left side. And here, if you have a point on the right side, then it's through the origin that you would have a corresponding point, but they would have opposite signs. Now, I would like to take another look at it. I would like to think of this as the sine of 30 is equal to a positive 1/2. But the sine of negative 30, that would be on the left side, is equal to a negative 1/2. Well, let's look at the unit circle if you want to verify it that way. Positive 30 would be here and the sign is 1/2. But negative 30 would be here, and because you're in the 4th quadrant, it would be a negative value. So, the sine of 30 does not equal the sine of negative 30, but the sine of negative 30 does equal the negative sine of 30. So if you change the sign of the positive 30, well, sorry about that, you do get equal values. Now, on an even function, if you look at the unit circle, the sine of positive 30 is root 3 over 2. The cosine of negative 30 is root 3 over 2, and the cosine of negative 30 is still root 3 over 2. So the cosine of 30 is equal to the cosine of negative 30, because let's say this is 30 and negative 30. They both have a positive value, whereas 30 here and negative 30 have opposite signs for their value. So that's the algebraic look at the even-odd situation, and also if you think of the unit circle, that's another way of looking at it graphically. Now, to verify algebraically is simply to do this. If I know that g of some angle, and let's consider this the positive value, okay, is equal to this rule, then if this is an even function, then when I replace g with negative x, I get the outcome would be the same rule. But if I input negative x in the rule, I get opposite signs, then I have an odd situation. So let's take a look at the algebraic setup. first thing I do is I replace my angle x with negative values. And I know that the sine of a negative angle is equal to the negative sine of that positive angle. So I can replace this with the negative sine of x. And I know when I cube a negative, I get a negative. Well, where is that going to lead me? Well, obviously, this is not the same as this. So I'm going to simplify. As a matter of fact, these signs are completely the opposite. And I can even re-express that as the negative of the sine of x plus x cubed, which means that g of negative x does not equal g of x, but I would have to change the sign in front to make this equal. So I have, sorry about that, oops, an odd function, because if I input a positive value, this is the outcome, but if I input a negative value for the angle, this is the outcome, which is completely opposite in sign from what I was given. Okay? All right, next. Here's my given function. If I input a positive x value, a positive angle, this is the rule. If I input a negative angle and I replace x with negative, the parentheses should be here, guys. Those parentheses should be here. So let me fix that. This should say negative x squared, okay? Now, when I square a negative x, I get a positive x. So that ends up being x squared minus 4, which is exactly what I had when I input a positive angle. Here, when I input a negative angle, I get the same exact answer, which makes this even. Okay. All right, same procedure. Here I have a function. The input is a positive x. This is what I get. This is the rule. If I input a negative x and I get the same rule, it's even. If I input a negative x and I get opposite signs, it's odd. If I input a negative x and I don't get opposite signs or the same signs, then I have a neither situation. So let's see what happens with this one. Here's the input. I'm showing the input. Now, the cosine of a negative angle is equal to the cosine of a positive angle. They have the same value. So I can just replace this with cosine of positive angle. And whenever you square a negative, you get a positive. So this is the outcome. So I get the same outcome with a positive and negative angle, therefore they must be even. Okay, finally. This has a lot going on with it, so let's see. I'm going to replace the input value with a negative angle, or negative x. Alright, so that's the setup. I'm just putting negative in here, negative in here, negative in here, negative in here. Everything is changed to a negative x. Now, let's take it piece by piece. If you square a negative x, you get a positive x. So I'm going to replace this with positive x squared. The cosine of a negative x is equivalent to the cosine of a positive x, because cosine is an even function. When I have a negative x, that just stays, nothing's going to change. But when I have a sine of a negative number, that's equal to the negative of the sine of the positive. So let's see what I have here. So this is x squared. Sorry. This would be cosine of x, because they're equivalent. Then I have the sine of a negative x will be the negative sine of x times the negative x in front would be a positive x. So that's x times the sine of x plus 4. Yeah, what do you think? How does this compare with the original? When I input a positive x, this is the outcome. When I input a negative x, I get the same outcome. All right, you ready? Did you say even? You're right. Okay, good job.